Hi, good afternoon. Welcome to this Azure conference. I'm Christoph, and I'm going to talk today about real-world architectures using Windows Azure Mobile Services. So let's get started by, for the people who don't know me, to introduce myself. So I'm Christoph. I'm working for a company called AppStory in Belgium, and we focus on mobile strategy. So basically what we do is we don't really build mobile apps, but we're really doing the strategy thing, starting from the ground up to build apps and to think about the processes needed to build those things. And we're not really focusing only on Microsoft technology, but all platforms, and that's why mobile service is really a great asset. So extra what I do is I'm managing the company, plus I'm taking care of all the technical stuff. I'm also part of the Meet team in Belgium, and since recently I joined the Azure Insiders list. Plus, for the mobile services specifically, I'm also on the advisory board where I try to help and shape the future of mobile services. If you would like to reach out, feel free to tweet me or to send me an email. Any questions, always welcome. I'm also part of the Windows Azure user group in Belgium, and what we try to do is we try to organize an event and a session every month or so and try to really focus on Windows Azure, the real high-level stuff, and to do some nice things. First of all, before we get started, don't forget, if you're interested in getting your hands dirty on Windows Azure and really get the thing done, the GWAB is coming. It's Saturday, so it's going to be a great opportunity. It's a boot camp to get you started on Windows Azure, get your hands dirty, and get a feel of how it's working. So to get started, what is going to be the agenda for today? It's going to be about mobile services. First of all, let's see, why is mobile services interesting? What can we do with it? How can we shape it? What's the benefit of using it? And then I'm going to take out two parts which I think are important when thinking about architecture in general using mobile services. First of all, it's about data. So what do you do with data? How can you shape it? How can you work with tables and data in your mobile service? Then a little bit about security considerations. How do you make it secure? Which are the internal parts which can help you build secure solutions? And some great tips and best practices which I found while working with mobile services. Then the next topic will be more about real-world scenarios. So I'm currently building a few projects for customers using mobile services. So the idea is really to see which scenarios can be covered by mobile services and how do we go from step by step through those. And then I've bundled some advice from the trenches, so about database, ALM, and architecture, how to really fit it into your company if building mobile solutions. And then we will end up by wrapping up and making a conclusion about the Windows Azure Mobile Services. So first thing is, question you could ask yourself before starting any architecture and before thinking about using mobile services for your apps is, why bother? Why is mobile services a great thing to look into when you're building your solutions? So first of all, it has powerful building blocks. So everything you need nowadays to build mobile apps is there from the start. You don't need anything to invent. Everything has been foreseen, and we'll go through all of those, and you will learn that indeed mobile services can be great to get started right away. So all of them are available out of the box. You don't have to invent those. You can start using them directly from the components which are available for you to get started right away. It allows you to build solid backends in seconds, and when we talk about mobile solutions, mobile apps, Windows apps, or even Android and iOS apps, the most important thing is that you can focus on your apps. That's also the way what customers are seeing. That's what they're paying for. So they really want to go fast, and they want to see your app as soon as possible. So you want to focus on your backend, but you want to have the backend as easy as possible with all the features you can imagine. And it has to work. It has to be solid. It has to be performant. It has to be capable of dealing with those many clients. So what is then the benefit of using mobile services? You get cross-platform support for all major platforms right out of the box. It's Windows 8, Windows Phone, Android, iOS, and HTML5 if you want to go for single-page applications or anything related. So it's really simple to get all of those up and running right away. So if you checked before, you saw the session which was previously broadcasted. It was about cross-platform development on mobile services. So if you checked out that already, it's really showing that the great power of mobile services to build cross-platform apps. So the other thing is, if the SDKs for all those platforms are not sufficient for you to build your apps, the API itself, mobile service, is fully REST capable. So in case you need it from any other system, you can always go for REST and just call the API like that, and you're all set, and everything will keep on working, and it will work like it should. So basically, if you're choosing mobile services, you can focus on your apps, and you don't have to focus on infrastructure and your backend that much. You can start writing your backend scripts right away. You just focus on your app, the functionality and the logic which you need to offer to your customers. So which building blocks do we have available right at our fingertips? So we said all of those components are available right out of the box. So the first one, which you will need in any app, is going to be data. So you're going to work with data from a read perspective. You're going to send some data to the backend. Every app nowadays is more or less using and reading data and showing them to the customers. So data is the most important building block for mobile services, and is the one you're going to use the most. Secondly, it's server-side logic. So the server-side logic allows you in the backend to shape your backend logic. So the idea is that the frontend is going to visualize the data, get input from the user, and send it back to the backend. But all the logic which you're implementing, it's important that you store it in one single place so that you can share it between all those client platforms. If you want to use a functionality from Windows 8, Windows Phone, it's important that you share it and that you only write it once. So server-side logic is foreseen right from the start, and basically it's the foundation for server-side logic is Node.js. So it's based on JavaScript. So why did I do that? Because importantly, they were focusing on cross-platform, and one language which is cross-platform is JavaScript, and that's why they chose JavaScript to offer to everybody to be able to work in the same way when dealing with backend scripts. Another thing which any app which you're going to be developed is going to have is authentication. So you want your users to be able to log into your service, to do some stuff, to log into Twitter, Facebook, Live, to do some custom authentication. So it's always important that your app, even though it's going to be connected to your backend, that users have the opportunity to authenticate themselves and let them know, this is me and this is going to be my data. So authentication really important. Another feature which any mobile app is going to benefit from is notifications. So you want your app to be responsive and to be able to send data back to the user. Something is happening in the backend, you get some new data, something important is available for the user. So what you want to do is you want to send back that data to the client, and you want to do it in a more push way. So you want to send some push notifications. And on those, the Windows notification service, the Apple push notification service, and the Google push notification service is available right at your fingertips, straight from the server scripts, and you can start working with those right away. Scale, which is of course important. You're working with a mobile app, you're working with a mobile backend, so you can never imagine how many clients will be out there. So you start small, you start with scale unit 1, and before you know it, there can be thousands or millions of users of your app if it's really successful. And then you would like to have a scalable backend available right at your fingertips so that when it happens, you can scale up and everything will still remain running smoothly. So scaling is built in right from the start, and you can use it whenever needed. And then, of course, any application, any backend is going to cause some issues, performance or some bugs which appear, some crashes, some data which might be working not correctly. So that's why you want to have logging and diagnostics available. So you would like to go into the process on the backend and see what is really happening. You want to log some stuff, you want to look into diagnostics, you want to deal with those things. So logging and diagnostics available for you, so right away for you to get working with. So the first part which we are going to cover today out of those building blocks is data, because I believe that it's the most important one to start, because it's going to shape your application, and it's also the one which can determine the success or the failure of your app. So before starting to talk about the possibilities with data, to show you how the foundation of data has been created. So it's founded on Windows Azure SQL database. So the idea is that there is a Windows Azure SQL database running on Azure. It's storing your data, offering your tables and access to the data. And the API is written on top of it, and it will expose that through OData, and it will expose your database so that you can start using it from your client. So when working with a database, of course, the first thing is that you're going to work with tables. So there are several ways to start creating tables. So, or you can do it through the portal, or you can do it through the API. So when working with that database, it's important that you create your structure of your database right from the start, and that you start thinking about how am I going to store my data, and that you start creating your tables, and you can choose to do it through the portal or through the API, through PowerShell. So the extra benefit of it is that when creating a table, the only column which is going to be there, the column which is going to be required, is going to be the ID column. So for the rest, I advise you to keep looking into the dynamic schema feature. So mobile services offers you a dynamic schema feature, which will make sure that anytime you send data to the backend to store, to persist, that any field which is available in your object is going to be added as a column in your table, which means that your schema is going to evolve automatically, and any type which used in your entity is going to be directly mapped to a column type in your database. So if you use a string in C#, it's going to be an nvarchar in your backend. If you use a datetime, it's going to be a datetime in your backend. So by working like that, you just create a table which only has an ID property. You enable dynamic schema, which is enabled by default. You start inserting data, and your data structure will shape itself when working with it. Another thing which is important to think about is that even though you're running on a SQL database, you can still use that single database for multiple services. So it means that we have multiple mobile services, and you can share one SQL database throughout all of those. And it's something which I really would recommend, because the price of mobile services is pretty low, but when bundling multiple mobile services into one database, you can optimize the usage of your SQL databases on Windows Azure by doing it like that, which I will show you later during some demos. Remember, when using SQL database, every mobile service is going to get its own schema where the tables are going to reside into. And the security for mobile services for that database are going to be based on that security, on that schema. So security is schema based, which we'll see later on during the demo as well. And when you're creating a new service, a new mobile service, you need to use the DBA user to be able to create it. So the administrator account of your SQL server is required to create a service, but it's not that user which is going to be used for further access. It's going to be a separate user, and again, when we are going to talk about security, I will show that all into detail. If you're working with your service and you're going to get throttled in some way, which is possible on SQL Azure, there are some limits, but hard to get to those. But in case you do, throttling and failures are handled in the API itself, and retry logic is available for you. So if you call your API and for some reason the connection to the SQL would fail because of throttling, the API itself will retry again, and you as a client, you don't have to deal with that. So a question which you get a lot is, when working with Windows Azure Mobile Services, even though it's based on a SQL database, what about relations? How do you deal with relations in your data? Basically, the conclusion for that is pretty simple. Relations are not possible. So every table is existing on its own, and it's not really possible to put foreign keys and stuff like that by default. But if you really want to, you can always use views. It's possible, but I would not advise that. The way to do that is you create a view directly on the database, you give it a certain name within the same schema, you write your complex query there, then you create a new table with the same name, and instead of creating that table, it will link that name to the view, and voila, you have your view up and running and your complex query, which you can expose through your API, start querying and executing your query and your data in a different way. But I wouldn't advise to do that, and I would advise to look into the SQL database as being something without relations, and more see it as a table storage thing where you also don't have relations between your different tables, and I would start using it like that. But of course, if you want to, and you have multiple tables which contain data, and you want to create an endpoint which exposes that data in one go, you can always aggregate that data in a service-side script, read it from there, put all the data together in one JSON result, and send it back to the client. I have some scripts available which I will show you later on. So this brings us to the fact that we have server-side scripts, but those scripts are not always tightly linked to any table, to single table. So it means that in the server-side scripts, in the read or insert even, you can do any logic which you find appropriate for implementing your backend. So, for instance, it can execute HTTP requests. It can call any HTTP endpoint out there. So if you want to integrate with other stuff, you can do. Like, for instance, you can call table storage, you can call blob storage, do some service bus stuff, or even call a third-party API like Facebook, Twitter, and Live. Really simple, and I have a sample script out of that which we'll go through during the demo. Being secure. We're working with a database. So basically, as I already said, there is a separation on schema. So every table is going to reside in a single schema, but users are also going to be separated. And this means that you use a DBA account to create a new service. It's going to be created, but in the backend, it's going to generate a new user for you, which is going to be available to call to use the database in the connection string. So it's going to be a locked down user which only has access to that schema, and with that user you will not be able to access any other tables. Secondly, when looking from a security point of view, we have the application key. And the application key is the one which you use in your mobile service client when working from .NET to connect to your backend and do some calls with your code. But more think of it as an application identifier. It's not really an application key in the sense of, it's a security mean. No, it's really the application identifier to indicate this is me calling your API. So basically, it only remains private during development. Once you release your app into production, consider it to be compromised. It's not private anymore, and people can just figure it out from the code. Like for instance, for Windows 8 app, you just take the installed location of the code, you decompile it, and you will find your key, and it's not safe anymore. So never rely on it to remain private in production. Always think of it as compromised, and basically don't use it as a security mechanism. Only use it to track users. If you want to know the user who is now calling my API has my key, it's a good way to track, but it's not a good way to use security, because it's not guaranteed to remain private. So anybody who found the key can call your service with the key, and if you're using security based on that key, it's not going to work well. People will be able to delete or add data in your backend without you being able to check it. So how do you deal with permissions then, if you're looking for the application key? So the first type of permission you have available is everyone. So which means everyone calling this API has access, and nothing on security level will be checked. So my advice is use that at all times for read and for anonymous access. If you have some tables where everybody can read the data is not really secure, go for the everyone permission. Then the second one is anybody with the application key, which is the default one when creating a new table in Windows Azure Mobile Services. So you could use that for read, as you did for everyone. You can use that for insecure inserts. If you say I have a table where people can insert data like tracking, saying this is me, I'm calling this screen, which doesn't really matter if somebody is really injecting something which you don't want to, or some logging. Or you can use it for tracking to know that indeed the client currently using the API is that guy. The third one, which is the best option when dealing with secure systems, is the authenticated users. So it's the only option if you want to build a secure system with mobile services, and you should use it for client-server communication. So every time you have your client communicating with your server and doing inserts, doing reads, doing anything on your backend which requires authentication, you need to use authenticated users, and then the authentication building block of mobile services comes into play and can allow your user to log into Twitter, Facebook, Live, or Google and provide those credentials back to the backend, which will then be used to secure that service. And then the last option, which is really interesting, is the only scripts and admins option. So when looking into your mobile service, you have your master key available, and your master key is the one which you will be using for adding scripts, which needs to be secure, and I would recommend it. Never use it for client-server communication, because the master key is really the master key, but use it for server-to-server communication. Let's say that you have some worker role in the backend running on Azure, which is going to fetch some data and insert it into your mobile service. It's clearly server-to-server communication. No way that anybody is going to compromise the master key. So great way to do the master key. Other option is you have another web application which might be getting some data and inserting it into your mobile service. Great thing to do with the master key, because it's virtually impossible for somebody to get your master key. So let's now switch back to our mobile service portal and see the things which we now saw from here. So basically, I have some services available which I'm currently using. So if I open it, there's a tab data which will show everything which I need. So it shows me my tables. I can drop into that table, browse, see the data which is currently available, see the columns which are there, which are based on the dynamic schema. I can browse my scripts, see the insert script, the update script, the delete and the read script. I can see my columns and I can see my permissions. So currently this is set with anybody with the application key. Looking into the scripts, I have a lot of options. So looking into the read script, what I do here when I'm looking into this script, I'm not really reading directly from the table. I'm doing a little bit more stuff. So what I wanted to do is, this table is storing favorites for users. When they're working with their app, which I will show you later, they can store some data as their favorite and mark certain records in the app as being their favorite. Now, what I could do is I could have created the table as being user ID, session ID, and all the data being put in here as one record. So that means that one single user ID could have multiple session IDs. Great deal, but I want to optimize this data structure and not always send too many records over the wire, but only send back one. And I would like to optimize it, saying I have one user ID and it can have many session IDs which are concatenated by commas. But by default, the mobile service backend is not supporting that. But as I said, you can have custom sources. You can implement the script as whatever you want. So if we look into the read script, we see that every time we execute the request, and the request is successful, we're going to convert the results and going to convert it to a single object. So converting is creating a new JSON object, looking, do we have any results available? Then we just create a new results. We get the user ID from the first result, we get the version from the first result, and we create a new array of session IDs. And then for any session IDs we find, we split them on comma. We're going to do a for each on that list, which is basically any default JavaScript function. We're going to call a function, and if the session ID is not null, we're going to push it into that array of session IDs while parsing it to an int. And we're going to respond the user back with HTTP 200 and that result. So instead of calling that backend and returning back the an enumerable of results with user ID, session ID, no, we're going to get back a single user ID and multiple session IDs in a JSON array containing all of those. Which means that if I would look into my code, and I would go to my code, and I would look into my my object, it has the user ID, and it has a public int array of session IDs and the version. So in code I can just work with the array, and when I read from the backend, it's going to be converted from a single property comma separated into an object which I have in my code. And when doing the insert, it's pretty simple. I do it vice versa. So I get the favorites table. I say, give me where user ID equals the user ID which has been sent in the insert. When it's success, do an update or insert. And when there are any favorites found, get the first one, update the version, and update the session IDs by joining them with a comma, just a standard JavaScript function. Update that record and respond back HTTP 200 to the user. If not, if this is a new one, create a new favorite, which is just a JSON object, put user ID, version ID, join the session IDs by comma, and insert it into the favorite table. So by doing this, I optimized my data flow, I optimized my bandwidth, and I made sure that when working with this, that I can send back and forward the data in a pretty simple way. So secondly, yeah, the permissions we already covered. We covered the insert scripts. So what can we do else? We have the identity tab where we can configure our authentication. So in this case, we're authenticating using Windows Live. So we have the client ID, client secret filled in. Configure, we have linked this to our database. And we have our scale tab. So now what I would do is I will connect to the database and show you how it looks like if we really look into it from Management Studio. So how do you do that? You go to database, servers, you pick your server, you go to configure, and you add your allowed IP address into the list of IP addresses which can access this data based from outside. So basically you're opening your firewall to be connecting to the database. So if we look into this, Management Studio, I get my table, my database, and all my tables are into the correct schema. So these are the tables for this mobile service, which has a schema mstd belx 13_dev, favorite filter me, and then I added 2 other services into the same database, which have an app story service 1, service 2, and service 3, and with some tables. So if we look into the security, of course, there is my main user, which I use, which is my DBA account. But I have some plenty other accounts which are pre-generated by me, which have some strange names, and which can be used to access this database when working from the mobile service. So if you look into the security, the users having access to this database are these guys. So if I would take one, script it as a create, you will see that it's going to show you that it has a new user with access only to that schema. So that login user for login, that login with default schema app story service 1. If I take the other one and I do create, it's going to show you the login for app service 2, and then the last one. So I have 3 mobile services running on this database. It's the 3rd user, which is available and access only to the mstd belx dev schema. So which means that even though you're using the DBA account to create your your mobile service, it's never going to be used by that mobile service to access the database again. So it's a good, it would be a good way for your DBA to get convinced in using mobile services, because the question they will ask is, okay, I'm using the DBA access, but no, behind the scenes it's using a slimmed down user which is only be used to access this. And we will get back to this later when we do some other nice stuff. So when going back to the slides now, to go and talk about the real world architecture, so how you can fit in these things which we saw now, and look into how you can apply it into real-world architectures. So the first scenario which I'm currently using mobile services for is to use it as a mechanism to synchronize data between 2 apps. So the application we built for Microsoft for the Microsoft Tech Days Belix event in March, we developed an app both on Windows 8 and Windows Phone. And people could use that app to browse the sessions, to browse the agenda, to see some speaker details. And the idea of the app was that somebody could go to the conference and build his own agenda and to figure out which sessions he wanted to follow. So the challenge we had there was that a user could be using Windows 8 on his machine at work, build his agenda, and we needed to get that agenda to the phone side so that he could walk around in the event with his phone and see which sessions were his favorite, which session he needed to go next. So that's why we went for mobile services to do data synchronization. So any app which has data which can be shared over multiple devices and platforms, like settings, user data, it's great to do it using mobile services because it's pretty simple. It's available right at your fingertips, and you can get started right away. So mobile services can easily be the store in between those apps, store the data for you. It's a pretty simple structure and allow you to access that data from any source. So how does it look like? It's the one I showed you before. I will drill into the code right away. But how does the architecture of the app we built looks like? We have a Windows 8 and Windows Phone app. So basically there are two tables which are synchronizing data. So we have one, the table of favorites, which sessions you would like to see during the event. And then we have filters. In the app you can filter data which on your preference. And those filters are also synchronized so that when I'm also only interested in sessions for developers, that I'm only seeing those and that it's synchronized between devices. So in between we have mobile services using Microsoft account as an authentication mechanism, using one SQL database with 1 GB, it's a web edition, and then 3 instances of mobile services during the event, and we scale back to 1 instance after the event. And then on the Windows Phone side, we used XAML and C# with the Live SDK, and some REST, because for integration with the mobile services, at that point, the SDK for Windows Phone wasn't available yet, so we had to go for the REST implementation. And then on the other side, on the Windows 8 side, we just use XAML, C# and MVVM, and we use the Windows Azure Mobile Service SDK. And the third scenario, which I'm going to talk about today, is also going to be about this. So if you look into the app now, it's pretty simple. I will show you. What I can do is I can start up the app, and what I see is I can see the full program, and when I'm looking into the full program I can filter my data. So I can say I only want to see developer, I want to see some levels, but what I could also do is I can go to settings, and then it will ask me to authenticate. I log in with my Live ID, which is this is the Windows Azure Mobile Service, the authentication broker for Windows 8, and I'm logging into Live with this. I'll log in, so now it's going to get back into the code, and now it linked in my settings, it linked me, it enabled synchronization, it said synchronize filters and synchronize favorites, and if I now synchronize my data, it synchronized both my favorites and my filters, and if I now look into my program, it has some days available. So you saw that the left side updated and showed me these are my favorite sessions which I would like to follow. So even if I'm working on multiple Windows 8 devices, I will be able to log in with my Microsoft account and synchronize those data to the backend and back to my clients. If I would do this from the phone, it would work exactly the same. So pretty simple to do, pretty easy. So in the backend, like we saw before, what do? We store, if you look into the mobile service, what we store is we store favorites and filters, and favorites contain a user ID and the concatenated list of session IDs and a version, so that we know which side has been updated first. And then we have a filter which has all the fields, tag, level, audience, version available for me right at my fingertips. So this is the first scenario, which is pretty simple to deal with. So the next one is about data aggregation and consolidation. It's an app which we are currently building. And imagine you have a solution, an app which you need to build, and you have data coming from many sources. It can be a database, it can be a data feed, it can be a content management system, a website where you're going to get some data by scraping or by any other mean. And you need to build a solution or an app that's going to visualize this data to your customers. So it might be tricky to do. Why? Because you have the risk of tightly coupling to various sources. So it might be possible that when working with a database, CMS, website, or feed, that you're tightly coupling your app to those sources. So yeah, what happens in case the source structure changes? What happens if the source is down, the data is too large, or new sources need to be added? The problem is that any of those things are out of your control. If the structure of the source changes, your app is going to be broken. And recently there was a case, somebody implemented, had a great app running onto a public API. The API published a new version, they didn't version it properly, and the app was just broken. And if it's broken, it takes, when you need to fix it, you need to submit a new version, and it might take some time to get in the store. For Windows 8 it's pretty fine, but for phone it might take some time to get that new version up and running. So you don't want that to happen because it might influence the quality and stability of your app. So you want to be able to deal with that. The same if the source is down. Let's say that you're connecting directly to the source and for some reason it's down. Yeah, your app is not going to be functioning properly anymore. So you never want that. So a case for this app which we're currently building is an app for the Microsoft Partner Training. So the MPN, the Microsoft Partner Network. We're currently building an app which will allow users to browse trainings which are going to be done by Microsoft partners. So it could be trainings organized by Microsoft itself or by Microsoft partners, or by Microsoft Innovation Centers, by a lot of different sources. So we have to visualize data coming from the Partner Trainer Framework, from Microsoft Partner Network, from DPE, from the Microsoft Innovation Centers. So, for instance, the Partner Trainer Framework is SharePoint. The MPN is a SQL database running on Windows Azure. DPE and MIC are just using data feeds coming from showing XML. So our goal is for this architecture to work with one data model. So instead of all those different sources of all their own data models, so which is really difficult to work with from a single app, so we need some translation mechanism in between. So our focus is to support one data model and to offer the app one data model which we control and structure which we can work easily with in our app. And then the only thing we need to do is transfer the structure and translate the structure of the source into the structure we know, and the app will never notice that it's a different source and will never know that where the data is coming from. Plus, extra benefit is, for us, we only have one interface, one endpoint which we need to call, which we control ourselves, and we can easily work like that. Plus, it's adding reusability. So currently we are building a Windows 8 and Windows Phone app, but of course in fiscal year 14, which is starting as of July, we're going to go for an app on Android and on iOS. And by choosing Windows Mobile Services, we have the SDK available. We can easily add that client and get it up and running in no time, because we know the structure, we can share, and we can optimize the code reuse, and we're all set. So how does it look like from an architecture point of view? You have all the sources, SharePoint, SQL database, XML feed, anything else which we might not know of yet. We have some integration services running. It could be a worker role, it could be a Windows Azure Mobile Service scheduler, which is also available, a scheduled task which runs every 15 minutes. It's going to pull the data from those sources, it's going to translate it into its own format and insert it into the mobile service database by using the API. In this case, using the master key, as we saw before during security. And then all those apps, the Windows 8 app, the Windows Phone app, Android, iOS, and potentially a web app are going to connect to the mobile service, getting the data in the format we know and going to show it to the user. The third one, which you will also find interesting, is how do you integrate your solution using Windows Live. So you have two options. You have Live SDK and mobile services. And basically, they're integrating pretty well. So if you're using Live SDK on Windows 8, it's single sign-on. It gets the credentials which you're logged into your Windows 8 machine. You can easily pass that token onto your mobile service client, and it's going to work out of the box. Nothing has to be done. It's going to work pretty good. But the only thing which is a little bit challenging at the time is, what if you use Live SDK on one app and mobile services on the other, like you could be doing already? The case which we had is, for those apps, since the mobile service SDK for phone wasn't ready yet, we were using Live SDK on Windows Phone and mobile service application on Windows 8. And the problem was that the token you get back from either one of those is not going to be the same. So you get, when you do an authentication, you get back a token, and that token can be used to call other APIs, and you get back a user ID. And the user ID is an indication of who you are, and it's that user ID which you normally store in the backend to link data to a certain user. The problem is that the user ID you get back from mobile services and the one you get back from Live SDK are not the same. Why? The one you get back from mobile services is in the format of Microsoft account, and then plus an ID. It's a different format, and the ID, the reason for that is pretty logical, because mobile services support many different identity providers. You can log in with Twitter, you can log in with Google, you can log in with Microsoft account. So it's normal that it's a different format, it's a different user ID. And if you log in with Live SDK, it's going to give you back the UID property of your user available on the Live API. And those two user IDs are not matching, so it's not the same. So it's pretty difficult to link the data to a certain user and to know on both sides that you're indeed talking about the same guy. But there is, of course, a pretty simple and nice solution for that. First thing you do is you authenticate to Live SDK the normal way. You get your token and you get your user ID. You, on the phone side, you use that token to call the Live API and you get the user ID back from that user. It's the real UID. The second thing you do is on the other side, you authenticate using mobile services. You get a second token and you get your user ID. And in a server-side script, what you do is you call the Live API to fetch the real user ID. And even though the two tokens and the two user IDs you got initially are not the same, the user ID you get back from Live API is going to be the same. And again, the app which we are currently using has this challenge. So we had a Windows 8 app authenticating through Live using mobile services. The reason I didn't go for Live SDK here is because I really wanted to get the authentication broker so that the user could be able to log in with a different account. Because in my case, I have a phone and I have a Windows 8 machine, but they're not using the same Live ID. And there were a lot of other people had the same issue. So Live SDK on Windows 8 only supports single sign-on, so using the account available on your device. So I would have been stuck on that one. And on phone side, we use Live SDK. So how does it work? From phone, you directly go to Live SDK, you get back the UID by calling the Live API, and you have the user ID. From Windows 8, you have to do one step in between. You call the mobile service SDK, authenticate through Live, and then through a custom read script, ask with that token, call the Live API and get back the UID and store the UID, and you have all of those. So to show you the code, it's pretty simple to do. So I'm going to debug it and to show you how it works into code. So I have here my authenticate methods, which I'm going to do. So if I start it up and I'm going for synchronize, I'm going to shut it off and put it back on so it triggers the authentication again. You see that I'm just using the mobile service client to authenticate using Microsoft account. So if I step through, it will show the authentication broker and ask me for my credentials. So I just log in with my Live ID like I would normally do, and then I get back a result which has a mobile service authentication token, which is a pretty long one, and a user ID. And user ID is in format Microsoft account and then some ID. This is the really ID, user ID, only can be used with mobile services. So you see, I don't have any other details. I don't have the user first name. I don't have any user details, email address. So basically, when I want to visualize who am I, it's pretty difficult to do. But you see, an extra call I do is get me based on that token. Now I will show you what happens if I go to me. I created a new endpoint me on my mobile service, which doesn't contain any data, only the ID property. But in my script, read, I implement some custom logic. So the first thing I do is I get my identities from my user. So this table is set to only authenticated users. So I know that every time I get into this script, the user object I get back is going to be filled in. So I get my identities. If the Microsoft identity is filled in, I get the access token from the Microsoft identity, and I'm going to handle the Microsoft account. Else, I'm going to return back a bad request because I'm using an identity provider which I don't support. I'm going to create a new HTTP request to apis.live.net with that access token. I'm going to request it. If it's not HTTP 200, I'm going to return back a server error. In the other case, I'm going to parse the JSON body I get back from that API. And I'm going to create a new me object where I set the ID, which is the UID, the user ID, the name, first name, last name, gender, locale, and updated time. And I'm going to respond to the user with that object. So this is what is going to happen here. So if I step through this, it's going to call this script. It comes back, and me object has my first name, Christoph, my last name, Renan, my locale, my full name, my ID, and my updated time. And this ID property 44D7, it's the one which I can use to store in the backend, and it's really my live user ID, and if I use it from the phone side, it will be the same ID, and by doing this, I linked both sides in a pretty simple and easy way. Extra benefit is, when doing this, the script I have here, I can easily reuse it, expand it to go to Facebook, to Google, to fetch some data from my user, and it's pretty easy to work with, and it's going to be hell easy to share this script between all of those different apps which I'm going to build. I just have to store this script locally, upload it whenever I need it. So these are the real-world scenarios which you would like to look into if you're looking for mobile services. And like you see, it's pretty simple to get started with it and to get it integrated well. So what I added into this talk is some extra advice from the trenches, so things which I've noticed during development of these things. First of all, on database level, what I would recommend is, even though you're working with multiple mobile services, you can always go for one database. It's pretty simple to optimize. You have one SQL database, it can still grow and it can still become bigger, but you have your mobile services linked to one database. In case you ever want to switch your mobile service to a different database, you can easily do it through the Configure tab of your mobile service and link it to a different table, to a different database. So it's not really restrictive to go for one database. Because, like we already saw, each mobile service has its own database user. So it's no reason to think that the security is going to get compromised. It's really secure. There's one user per schema. I would advise you to keep using dynamic schema most of the time during development. Once in production, the schema is not evolving anymore. So which means that every time you insert data, the schema is going to update it based on the properties available in the JSON object. If you really want to use complex queries, you can do it in the read script and write it custom and combine data from different sources like I did, or you can go for a view, but it's not currently the real recommended way, but you can do it if you really want to. And when working with these scenarios, it's a good thing, like you would do when working with a NoSQL approach like table storage, to duplicate and optimize data if needed. Let's say they have multiple tables. Since you don't have joins, it's a good idea to duplicate certain data so that you can easily find your way around your data model. And if you really want to, in your server-side scripts, you can access table storage, queues, another API, anything you want. Secondly, which I know that a lot of you guys are already doing, is it's really easy to fit mobile service development into your application lifecycle management. So what I would advise is, since the scripts are only available server-side, is to version your server scripts together with your code. So just store them locally, somewhere in a folder in your solution. Version them so that if you change them, that you know that you can track what changes have been done. Unit test them. It's possible to unit test them using JavaScript. So unit test them properly, and work with it like that way. And automate your script deployment using PowerShell, which I will show you right away. Test it properly, and like I do, separate your scripts into different environments. Use a development environment where you can upload your script, test it out, see whether it works. I had various scenarios where I uploaded the script and that I made a small mistake and that it failed. So it's annoying. You have to look into the logs and to start really adding some debug statements into that script to see what is happening. So I would recommend you use those three environments: dev, test, and prod. And when going to prod, keep it automated deployment. You have the scripts, deploy them using PowerShell. And on an architectural side, what I would recommend is, even though you're working with a mobile service client, abstract the implementation and loosely couple it. Like I do, what I do is, in my code, I add an interface on top of a wrapper around mobile service client. I call it iMobile Service. I inject it through IOC, use a dependency injection so that I can easily replace it with a new version, or with if I want to do some other operation, I can easily reuse it throughout my code, so that you can grow into it. You start small, you add some operations, and you can grow into it and abstract it using IOC and dependency injection. Currently, there's already a pre-release version available of the portable class libraries for mobile services, and I'm currently using those to share my code between Windows 8, Windows Phone, and even some web. So I'm using the PCLs to shape my code on my view models, on my common, on my DI container, on my and on my mobile service implementation. And because I'm doing that, I can easily share the code between Windows 8 and Windows Phone. So I only have to implement the logic to communicate with mobile services in one place, authenticate in one place, and call it just from any project which I want to, and get everything up and running. So also think about multi-tenancy. So it might be possible that users are working for different customers, and that your customers want to access their own service. So you have two ways of doing multi-tenancy for mobile services, or you just rely on one database, multiple services, and schema is your tenant. So it's one schema per customer. It's a good way to do that like that. So basically, if you do it like that, it's going to be handled for you. Secondly, what you can also do is just foresee a database per customer and implement multi-tenancy like that. But keep in mind that it's still an API which you're working with, and any best practice which you're currently implementing on any regular API also needs to be done on mobile services. So versioning, data formats, data optimization, and duplication, like I did, still are concerns which you have to take into account when thinking about architecture and when using mobile services as a solution. So to get into this ALM a little bit more, I'm going to show you how you can use it from a command line. So what I do is I've set up a folder with some scripts. So what I have is I have PowerShell available. I installed the command line tools for it. So what I can easily do is I can start querying my Azure mobile services just using PowerShell. So the first thing you want to do is, when setting this up, is you want to link your Azure account to here. So you have you can ask which Azure accounts you have. So I can, for instance, Azure account list to see all the accounts I have. I can set one account as my default. Account set, I'm going to set my development account as my default. So now every operation I'm going to do is going to be in on this account. So now I have something available, Azure Mobile, and this is going to show me all the commands I can do on my mobile service. So for instance, I can list my mobile services. So I can say Azure Mobile List, which is going to query the API and is going to say, okay, these are the mobile services you have available in this subscription. So what else can I do is I can list all the tables which are available in this subscription. Mobile table list, and I always have to put in the name of my my mobile service. So it's going to request now which tables do you have available. It's going to execute, say back basically what you see in the portal. These are my tables, these are the rows which are available into that. What else can I do is I can, for instance, download the scripts which I have available. So let's say that I want to create a new table on my mobile. You can do it through the portal. Like I said before, you can do it like this way. You can say mobile, Azure Mobile, so the command, table, create in the App Story Service 1. So if we go back into the mobile service, we see that Service 1 has table 1 available. So I can easily say, okay, in App Story Service 1, create a new table and call it table AzureConf. So it's now going to call the API and going to create a table like I do through the portal. And if I would now refresh my schema, you will see that it added the table AzureConf with a default column of ID, which is a big int and an identity. So now you would like to start in your ALM by uploading your scripts. So what I did is I created a default read script, which you see here, which basically contains the default script which you need, a read with a query, a user, and a request. So I would advise you to create inside your solution a new folder. So I would create a new dir and I would call it, okay, I have App Story Service 1 already. So I go into that service, and there I have I have two folders available. table and scheduler, and table is the place where you would like to start working with your scripts, and this is the format in which you define your scripts. Table name dot operation dot JS. So if I take that default script, I would place it here. I can say table AzureConf dot read dot JS, which is my default script, and I can use, like the commands you see here, I can use mobile script upload service name script name. So I say mobile script upload service name is the first one you have to pass in. So the service name is app story service 1. The file I would like to upload is table slash table AzureConf.read, and the table where I want to send it is it's a table script, and I want to send it to table AzureConf.read. And I forgot to add Azure on top of it, so it's always Azure Mobile, Azure. So now it's going to upload the script. And okay, so let's see from the portal, if I go to App Story Service 1, it creates a table, going to the script, going to read. It's basically empty script. If I add something here, oh, this is my default script. Okay, I will open it from here, like this, and you upload it again, and I will go to the portal. When it's finished, it's done, and you refresh it here, you'll see that it will show you the text which I added now, and the script has been changed. So it's pretty simple to write a PowerShell script which reads all those scripts and does it in a loop, so that you only have to write it once and can always update your scripts into a loop pretty easily. So by doing this, you can version your scripts locally and have them still being sent to the server. And the same can be done for the scheduler, which you can easily add a new job by using Azure Mobile job create and upload script upload service name, the file, and then instead of table you just use scheduler slash and then the name of your scheduler. So by doing it, you can easily see the Azure Mobile table list. Okay, I have to provide my my list, and I can see whatever is happening. And if I want to use a full, I can use Azure Mobile Show, and it's going to show me the full details of this mobile service. So in this case, it's going to show me status is healthy, the name, where it's configured, which database it's, which database server, the URI, the application key, the master key, the workspace, the region, and the tables which are currently available. And this is really a nice way to do it. So you also see directly which scale mode you're in, and if I want to, like you see here in the commands which I have available, I can easily change my scale and say no, scale to 3 or 4 units, and I can really go like that. So I would really recommend you fit it into your ALM, version your scripts locally, test them properly, upload them in different environments by using PowerShell. And if you have everything set up, you can even have your build server deploy your new server-side scripts and your new code right away and have everything up and running from the start. So to wrap up things, how I see it is it's pretty easy to start, even for free, and grow into it. So you start with a free mode and you grow your mobile service. You have killer components available and building blocks all out of the box. You have cross-platform support for iOS, Android, Windows 8, Windows Phone. And the benefit is you can focus on apps, but not on infrastructure. But remember, you're still building an API, and you have to consider an architecture it thoroughly and still think about the architecture as a whole. So like we said in the beginning, don't forget if you want to get your hands dirty on mobile services or anything out there, go for the Winners Azure Global Bootcamp and look into that. So basically this was my talk. I hope you enjoyed it. Thanks for joining already. Remember, mobile services is a great thing. It's still in preview, but it already offers you a lot of possibilities to build mobile apps, both on Windows 8, Windows Phone, and Android and iOS. I showed you a little bit about working with data and optimizing your data scripts to optimize your data, and showing you how to, for instance, integrate Live ID and Live SDK and Windows Azure Mobile Services authentication through Live. But remember, even though you're using mobile services and it's pretty easy to get started with, it might be a good idea to think it through thoroughly in your architecture, implement ALM properly, and fit it into your architecture using inversion of control and dependency injection. So I hope you enjoyed the talk. Thanks for joining, and enjoy the rest of the day. There's still some great sessions coming up. And if you have some questions, feel free to contact me by Twitter or by email. And hope you enjoy the rest of your day. Thanks. Bye.